Hello, my dear students. In the last part, we have discussed about the thrust, that is force exerted by the liquid, and it should be always perpendicular to the solid surface in contact with the liquid. And in this part, we have to discuss about the pressure exerted by the liquid. When you talk to liquid pressure or fluid pressure, pressure is generally force divided by area. So pressure exerted by a liquid may be defined like this. Instead of force, we have to consider thrust, that is force exerted by the liquid. So thrust acting per unit area of the solid surface in contact with the fluid is called pressure. And the pressure height are the unit area the piva force to level. Force in case of fluid or liquid thrust higher level. The thrust divided by area of the solid surface in contact with the fluid. Pressure and the pressure height are the force, that is thrust divided by area. Pressure की SI unit karino hargadi force divided by area haibnina force the Newton the measure tawani Newton per meter square lani. Aduga pressure je vector quantity ra scalar quantity ra hargadi pressure je hoi scalar quantity oigadi vector oide. Maramdi karigino hargadi pressure ki magi specific direction je laitaba. That is in case of liquid. Okay, so let us consider any point inside the liquid, that pressure will be exerted equally in all directions. That is, pressure has no specific direction, so pressure is a scalar quantity. So, high university my definition I might from other quite bottom years ago. So, pressure exerted by the fluid, it may be defined like this. It is defined as the thrust exerted per unit area of solid surface in contact with the fluid. If capital F be the thrust exerted on the solid surface of area A, then pressure exerted by the liquid is given by P equal to F by A. That is thrust divided by area of the solid surface in contact with the fluid. So from this, we may write its SI unit. The SI unit of pressure is Newton per meter square. That is, thrust or force is measured in Newton and area is measured in meter square. Aduna pressure ki unit might be Newton per meter square or Pascal denoted by PA. Pascal is a scientist meaning name of the scientist. My meaning Pascal hai ko. Aduna liquid na pressure na fluid na pressure hai talis might be there. Aduna mag SI unit say Newton per meter square smile level. And again, from this we can write the dimensional formula of pressure. Pressure is a scalar quantity. The dimensional formula of pressure is, we get like this: M L inverse T minus 2. See kind of line of pressure height force divided by area. Force the dimensional formula force the mass into acceleration. The mass is denoted by capital M. Acceleration of the meter per second square L T minus 2. Unit number 1. How to write the dimensional formula for common physical quantities. The force is area meter square. Unit say meter square. Meter have the length is L divided by L square is M is L by L square D. L inverse L over cancel to wrong, but the poradi power is minus 1 T minus 2 smile and CP dimension formula is CP lap. Now, dimension formula of pressure is a minor period equal. CP pressure is a scalar quantity or pressure is a scalar quantity. Mass vector quantity or the scalar quantity or because it has no specific or definite specific direction. Specific direction. Specific direction like this. If there's no specific direction, that is pressure exerted. Pressure exerted equally in all direction. Equally in all direction at the same level. At the same level. At the same level inside the fluid. Inside the fluid. And next we have to discuss about the variation of pressure with depth. That is depth of the liquid. Akoina pressure ga liquid ki magi depth ko adi liquid manu akoina point ama lawraba adugi point dugi magi depth ko aruba do aruba duga pressure ga kari mari de nage do putuk se ko. So variation of pressure with depth amu yeng se makha ko. So first we have to observe this figure in order to find out variation of pressure with depth. The variation of pressure with depth se apna discuss ko see figure jana yeng se ba. So here we have to consider a liquid at rest inside a container or vessel. For the part of the liquid ko, it may be water or air. See apna lay lower say. And let us consider 2 points, say C and D, inside the liquid having perpendicular distance small h. Sila ko na point ani lawra ba C ga D ga ko. C ga D ga makoy ani gi perpendicular distance h oire ba ko. Aduga sigi P1 jina sila is small P1 jina pressure at C. That is pressure exerted by the liquid at C ni. Aduga sigi P2 jina point D da leba pressure exerted by the fluid ni ba ko. So we have to find out the pressure difference, that is P2 ga P1 or P1 ga P2 ga and this is pressure difference putok se ko. So in order to find out the pressure difference between the 2 points at C and D, we have to imagine a liquid cylinder. Idala riba cylinder ja koina imagine taw se ko. Cylinder gi lengna ice oire aduga magi area of cross section na capital A oiba ko, such that the 2 points C and D lie on the two flat surfaces of the imaginary cylinder. According to imagine to riba cylinder jigi mamai ani flat surfaces ani the point C ga D ga laidoini aduga cylinder jigi magi leg na ice oire, that is C ga D ga perpendicular distance to oire adu sida la E sina according low riba cylinder jigi area of cross section oidoini. Then this imaginary cylinder is under the action of three forces, vertical three forces like a ko. Yung na haitare vertical the force of like a cylinder is the ko. Kari no fargadi say F1, that is thrust exerted by the liquid at point C or on the upper flat surface of the cylinder, and it should be vertically downward because thrust is always perpendicular to this upper surface of the imaginary cylinder. The third side the cylinder is the mamai to the perpendicular with surface of this F1 is acting vertically downward. Then the second one is F2, that is thrust exerted by the liquid at point D, that is on the bottom surface of the imaginary cylinder, and it should be acting vertically upward. This thrust is perpendicular to the bottom surface of the cylinder. Cylinder nugi makha thamba mamai da perpendicular way to act tawdaw ne ko aduna moise directed upward again. Then the third one is weight of the imaginary liquid cylinder. Akhoi loriba cylinder gi weight, that is W with the ko, and weight should be always acting vertically downward. So W is acting downward. The figure is the force of F1 haibama, F2 haibama, aduga W weight of the liquid cylinder. F1 acting downward oire, F2 acting vertically upward oire, aduga W is the acting downward when an emuka. The last is going to go. Sigi liquid se at rest la ibani aduna sigi imaginary cylinder su at rest la iduni leng na aduna total that is net force exerted on the cylinder should be equal to 0. That is F1, that is total upward force. Total upward force hai tadi bottom of the level force say F2 khatam koiradi ko upward. Aduga total downward force hai di F1 ga W ga. Aduga F1 plus W, that is total downward force se total upward force F2 ga managaneba. From that, we can find out variation of pressure with depth or pressure difference between the 2 points H, that is C and D, inside the liquid. Let us consider a liquid of density rho contained in a vessel in equilibrium of rest. C and D be the 2 points inside the liquid at a particle distance small h. A liquid cylinder having length h and area of cross section capital A with axis CD is imagined such that C and D lie on the flat surfaces of the cylinder as shown in figure. Our figure is liquid container or vessel da laire liquid se rest laire aduga liquid manung da point ani kak laure C ga D ga bakoi ani gi arapa se ice oire adu koi cylinder ama imagine tawre haiba cylinder jigi leng na ice oire adu area of cross section na capital A oire aduga magi CD sigi line passing through 2 point C is the cylinder jigi axis oidui adu di ko asida harise ar bathang da mu So next we may like this. We have mass of the liquid cylinder. The imaginary liquid cylinder mass on the or generally mass equal to volume into density. Volume with density ga protect over the mass function. So volume of the imaginary liquid cylinder is equal to area of cross section into height. Area of cross section ga cylinder की length or height ga multiply करके तारने अदर A is represents volume of the liquid cylinder अदर density mass per unit volume का unit volume का like mass तो फिर density ने अदर ना density into volume जे mass तारने बा generally फिर ना density फाइव तारने से rho जे density जे mass divided by volume का माने ये को अदर mass आई तारने volume into density by the लेके तो बने को Then again, so write equation number 1 and let P1 and P2, so let's say P1, P2 be the pressures at points C and D respectively. Liquid pressure of C and D, so the P1, P2, so let's say the liquid cylinder is under the action of following particle forces. See, liquid cylinder is the force act in the particle direction. Force of F1 F2 W weight of the liquid So the first one is force generated by F1. F1 equal to P1A acting vertically downwards at point C, that is on the top flat surface of the cylinder. See cylinder top flat surface point C force F1 where the direction downward later. The liquid force always perpendicular to the surface of the Similarly, force F2 equal to P2A. Force the pressure into area acting vertically upward at point D, that is on the bottom flat surface of the cylinder. Bottom surface has bottom flat surface of the cylinder. The particularly upward already, that is perpendicular to the bottom surface. Then weight W equal to mg, weight highly mass into acceleration due to gravity. Here g represents acceleration due to gravity, and mass will be equal to A is rho. That is from equation number 1. Equation number 1, the m value is A is rho g of the liquid cylinder acting vertically downward. When they always acting vertically downward, see liquid cylinder vertical forces F1 F2 W और next time लाखों इसे करीबो बो सिर्फ liquid cylinder जे rest लेबनी ना sigi force ahum sigi samje zero phangdoineba, that is total upward force equal to total downward force oiganeba ko. Since the liquid is in equilibrium of rest, the liquid cylinder is also at rest. Thus, net upward force is equal to net downward force acting on the cylinder. अब liquid से rest लेनी ना अपन imagine तो रिबा liquid cylinder जो rest ले रही अदुना liquid cylinder ले रिबा vertical upward total force का vertical downward total force का माना रही है अदुना downward लेबदी F1 का W को F1 plus W से total upward force है F2 माना रही है बनी अदुना F1 से right side तपरो तो this F2 minus F1 लानी सी W को माना रहे अदुगा force F2 दी अपन मांग द पीबदो pressure into area का माना रहे को F2 से अदु F1 ना P1 का माना रहे अदु W ना A H rho Z हम जितना मांग द E की बदुनी then capital A से कम्पल लवर का द both sides right side the level E is left side the level E is and is cancel secondly now P2 minus P1 is I rho Z tareba now P2 minus P1 is pressure at D minus pressure at C, that is pressure difference between the 2 points, that is C and D and C together, and this is equal to I rho Z. See the level ko now C D the level pressure ga C the level pressure and the difference I rho Z tare C ki equation number 2 na tai jeng ko pressure at D, that is P2 ga, pressure at C, that is P1 ga. Ani is kanan hai na solve which one is greater 530? P2 is greater than P1 because the difference between the two gives a positive value. See the fact is a positive value ni, I suppose is a positive value ni, aduna P2 is greater than P1 ni ko. P2 ni hai solve ni thai ni. So this means that pressure exerted by the liquid increases with increasing depth. Liquid से कोई ना depth आई डी लूदर का देखो हमारी pressure is increase तो ये दो सिना ताई दे बको और बतंग दमु ये सी मखा सतर को इनो को सगी करिगुम्बा सी की point P से sorry सी की point C से free surface of the liquid, that is liquid surface in contact with air को, that is upper surface of the liquid सी की liquid surface दा लेरम बाबा अभी ताकि सी जले को pressure P1 से कोई ना atmospheric pressure को रही है को अदुगो सिगी P2 सिना अखोइना प्रेशर एट D अखोइना कैपिटल P द रिप्रेजेंट तवसेबा अदुगो अखोइना कमाइना इबा यागे दोबो येंगसेबा को नेक्स्ट स्टेप दा और सिगी फॉर्मुला सिमा काउ याद्रे सिमा इंपोर्टेंट रिलेशन लेरे को और नेक्स्ट क्लास since I rho Z is positive value P2 greater than P1 aduna P2 minus P1 is positive value famabina P2 hena sorry haibani, that is pressure at D na pressure at C sorry hairani. This shows that pressure increases with increasing the depth of the liquid. Liquid की depth से सुम sour का मतलब जो सुम का pressure is increasing करने आगे. Then again, let us see another condition. If the point C lies on the free surface of the liquid, free surface है the liquid surface in contact with air है दिको. C की point C से सीधा लेरा बनी है दिको. अतो इतार दी P1, that is pressure at C से कहीं माना के वो pressure exerted by the air ni pressure manani, that is atmospheric pressure already bako, and again P2 do kena P ga manare na lo ro bako duga mo sagi D the level pressure P2 ja kena P ga manare na lo tar ga di sagi equation number 2 do smile la ne ba P2 have the P minus P1 have the PA equal to I rho Z aduna smile P which are ko P minus P1 equal to I rho Z. So here capital P represents total pressure at point D and P1 PA represents atmospheric pressure and this will be equal to I rho Z. और सीधा ले रिबा P minus P1 से अपन करी कवे द gauge pressure at point D है से है बको point D द लेबा gauge pressure no हाई बको सीजे बना known as gauge GAUGE को gauge pressure at point D no high level at point D gauge pressure at point D or the gauge pressure at a point inside the liquid the difference between the total pressure at that point and the atmospheric pressure is called gauge pressure high gauge pressure at a point is defined by GAUGE. See, gauge spelling smile like the gauge pressure at a point is defined as the difference between the total pressure at that point inside the liquid and the atmospheric pressure Finally define the gauge pressure at the point is